Graphing a system of linear inequalities. A system of linear inequalities has several inequalities to graph and determine which region satisfies all of the inequalities in the system. The overlapping shaded regions illustrate or show the region where the solutions for all the inequalities are, or the solution area for the entire system. In the example below, we can see that I have a system of linear inequalities where there are three inequalities. One at a time, we graph each inequality. First one that I'll take is the y is greater than negative 2x plus 1. So we would first start by plotting this particular y-intercept at 1. So on the y-axis at 1. We would use the slope of negative 2, go down 1, 2, and over 1. This would be a dashed line for the reason that this inequality has just a greater than sign. We're going to be shading above that particular line, so you can see in green I shaded above and to the right of it, and that's because when I use the test point 0, 0, I get a false statement, so I don't want to shade where the origin is. Now I move on to my second inequality, which is 3x minus y is greater than or equal to 3. This inequality is in standard form. I graphed this by first finding the x-intercept of 1. So there's my x-intercept of 1. And then I found the y-intercept of negative 3. I made a solid line on this one since I have a greater than or equal to. I use the test point of 0, 0 as my line does not go through 0, 0, and this is easy arithmetic. When I substitute 0, 0 into the inequality, I get a false statement. So I don't want to shade where 0, 0 is. Instead, I want to shade to the right and below it. Now remember, I'm working with this line 3x minus y is greater than or equal to 3. So that's what I'm shading to the right of, and I did that in purple. I have one more inequality to graph. That's y is greater than negative 2. This has only a single variable is y. The inequalities that have just the y variable are horizontal lines. This has only a greater than, so it'll be a dashed line. And the y value is negative 2. So I'm going to have a dashed line at the y value of negative 2. Now this is y is greater than negative 2, so the y values need to be greater than negative 2, and that would be shading above the line. And I didn't shade all of it above the line for the reason that I wanted to make this readable. I did it in pencil, so if I had done it all in pencil, it would be over here, but I only did this little region where all three colors overlap. So the solution to the entire inequality is this area that is to the right and sandwiched in between those three inequalities. This is the solution region for the entire system of equations. For students that are in linear algebra and probability, I want to remind you that when we graph systems of linear inequalities, we do the opposite on our shading because we're trying to find a feasible region, and we want to make that feasible region clear and readable. As a result, we will be shading all of the false areas, and that means the white area on your graph will be the feasible region, or actually the solutions. So that's exactly opposite of what you see here. Here in this particular video and this example, all of the overlapping area is where the solutions are at. If I were to have shaded exactly opposite, so the green line, instead of being shaded above and to the right, was shaded below and to the left. The purple line, instead of being shaded to the right, was shaded to the left. And instead of shading above the horizontal line, I shaded below the horizontal line. Then the white area, the totally white area, is your feasible region.